I welcome you all again to this course on mechanical and electrical systems of mining machine. So we are continuing with lecture number 24, that is on bucket wheel excavator, which is a part of module 2, that is fundamentals of mechanical systems in mining machines. The concepts that we would be covering in this topic are as follows. We will be first starting with the introduction to bucket wheel excavator. So a bucket wheel excavator looks like as you can see in the picture here, and then we'll be going to the history of bucket wheel excavator. Then we will be discussing on the general construction of a bucket wheel excavator. Then we'll be going to each and individual components. We will be studying in details about the bucket wheel, the counterweight boom, luffing arrangement, swinging arrangement, wheel drive mechanism, undercarriage unit and lubrication unit. Now when we talk about the history of a bucket wheel excavator, so there was initially this idea came from a dredger that was hosted on a river Weser of Germany. So from that first this idea was initiated, and thereafter something similar to a bucket wheel excavator was seen in Austria as in a form of Ludbeck mud mill. Thereafter there came the original design of this bucket wheel excavator, where it was used as a reclaimer. Well, thereafter we saw this first bucket wheel excavator, which was used for excavation, where there were buckets which were arranged at the front of a boom. However, the conveyor that is placed behind the these cutting wheels, they were unable to discharge it appropriately onto the conveyor, so that design was discarded. Then in 1883 came another design where all these cutting wheels, they are arranged in form of a bucket. However, there were also again certain practical limitations to this design, which again in 1913 there was a wheel which was designed with a number of buckets which are arranged on a common axis of rotation that we see nowadays in the bucket wheel excavator. However, while they were dumping the material automatically onto the conveyor, so there was a lot of material loss. So this was an old concept when there was different kind of cell which we will be discussing in details were made, which were not that successful. So that lead to a lot of material being there inside the bucket rather than getting dumped onto the conveyor. So that design again got modified in 1936, and the commercial production of this machine started. So when we see that this machine was first early started in Czechoslovakia, and then now we see Germany as one of the leading manufacturer of this kind of machines, and there are many countries which uses this kind of machines, including Germany, India, Poland, Romania, UK, US, then USSR and Yugoslovakia. So well, in India, when we see this bucket wheel excavator, so it is mainly used in Naveli Lignite Corporation Limited, where there are soft coal, which we call it as the brown coal. It is one of the softest coal, the lignite. So there these bucket wheel excavators are used. Well, you can see how huge these machines can be. So you can see a person standing herein, and you can see how huge this machine is. So the bearing pressure that is exerted onto the surface also has to be sufficient enough to carry the load of this huge machine. Well, now coming to the general construction of this machine, as you can see, there are wheels, series of buckets which are arranged on the periphery of a wheel, which we call it as a bucket wheel. You can see there are multiple wheels which are arranged around this wheel, Then behind it we have a boom which we call it as the boom conveyor, and this is or the wheel conveyor, where you can see there is a primary conveyor which travels through this boom, and it carries the material that is cut by this bucket, cut and collected by this bucket and dumped onto this conveyor systems. Now this material comes to the central part which we call it as the turntable, okay, or the superstructure. Now this superstructure and the turntable, this houses all the operating components, like there is the operator cabin is there, the diesel engine or the powerhouse if it is electrically controlled is there, and all the auxiliary components for running these huge machines are housed on this superstructure. Now below this turntable or the superstructure are the crawler units which helps in the forward traveling and backward movement of these huge machines. Now to the other part of this boom conveyor, there is a counterweight boom which helps in balancing the boom conveyor that is attached to the front wheel where the material is being cut. Now all the load of the material and the cutting comes onto this boom conveyor or the wheel conveyor. So in order to balance or maintain the stability of this machine, there is a counterweight boom which is given to counterbalance the weight or the shift in eccentricity of the whole machine that comes due to the loading of the material onto the wheel conveyor and due to the cutting operation that happens at the front of this boom, that is by the bucket wheels. Now when the material is transferred till this junction, then it get dumped onto this discharge conveyor. So there is another conveyor which is a discharge conveyor, and we also call it as the discharge boom. So through the hoppers it gets transferred onto this discharge conveyor, and again this discharge conveyor may directly go is connected to the belt conveyor. It can directly dump onto the belt conveyor, or it can dump at a dumping site where the material is again collected by other auxiliary machines which can carry this material to the designated locations. Okay, so now here for this discharge conveyor also there is a counterweight boom which is given, which balances the machine and the it balances this discharge conveyor boom while it transports the material. Now while we see this kind of constructions where the frontal attachment, that is the boom conveyor and the bucket wheel, they are balanced by the rope winch arrangement, which again is attached to this mast, which is generally a mast. Here you are unable to see a mast, but there is a mast through which this rope winch arrangement is goes through, and the winches are loaded onto the counterweight boom where it balances the frontal attachment of this machine. Now there can also be another construction where this frontal component is hydraulically controlled and where there is a hydraulic support just beneath this boom conveyor. So there can be two types of construction of the bucket wheel excavator, where we have a rope winch arrangement and the other is a hydraulic arrangement. Now when we talk about this machine, they can again be rail mounted and they can also be crawler mounted. When we talk about rail mounted, they have very less maneuverability. They cannot move as the machine desire or as the cutting is required. They can only move where the rail lines are laid. However, the crawler mounted, they can move on any uneven surface and the maneuverability is not an issue in this kind of machine. Well, when we talk about this equipment, how do we specify? As I have discussed in the overview class, these buckets are specified according to the bucket size. And what do we understand the bucket size? It is the inner volume of a single bucket placed on the periphery of the wheel. So what are the usual sizes? They may be 350, 500, 700, 1137 or 1400 liters. Please mark here, it is not in cubic meter but it is in liters. So a maximum bucket size can go as high as 6300 liters as is available nowadays. Now when we talk about this bucket wheel and the boom conveyor, it can move up and down and it can move also sideways. So this the moving up and down of this bucket wheel, we call it as the luffing arrangement, and you can see it makes a cut onto the rock mass or the ore body, which we call it as a terrace cut. Now while it is doing the cutting operation, it moves at an angle plus minus 30 degree along the horizontal axis. However, when it moves sideways, it is capable to move around 10 to 15 degree along the vertical axis, as is shown herein. Now when we talk about the different components of the bucket wheel excavator, so as discussed, in the front there is a bucket wheel where multiple buckets are arranged in form of a series around the circumference of this wheel. Then there is a wheel boom, or we call it as through which the boom conveyor or the wheel conveyor passes. So there are two names, we can tell it as a wheel conveyor as well or a boom conveyor. Then the other end of this wheel boom is attached onto the turntable, which onto which there are multiple devices or the components which are attached to. There is a transfer conveyor and boom which takes the material that is transported by the boom conveyor and is transferred through a hopper onto this transfer boom and the conveyor which passes through it. Now there is a counterweight and equalizer boom which helps in balancing the whole machine. When the eccentricity, when these buckets will be loaded with material, the eccentricity would shift towards the front end of this machine. So there is a counterweight boom which helps in the stability of the same. Then there is swinging or slewing system which helps in rotation of these machines at 360 degree angle. There is luffing arrangement which helps in up and down movement of this wheel boom. Then there are travel mechanisms which helps in movement of this machine. There is a undercarriage unit which is just above the travel mechanism, and this we also can call it as a superstructure. And there are multiple lubrication systems also which are housed inside this on this undercarriage unit. Now starting with the bucket wheels. When we talk about bucket wheel, so they are again of three types. They can be cell type, they can be semi cell type, or they can be cell-less type. Well, when we talk about cell type, what does it mean? So let's say you have a bucket that you use in your bathroom for taking shower or taking bath. So, or let's say you take that bucket and you fill it with sand. Now you try to rotate it. So again, if the rotation speed is very fast, it will not get discharged completely. So that is the problem with the cell type of buckets. So where these individual cells are, or the buckets are given with individual tubes, so the bucket gets completely filled. However, when they had to rotate, make a turn, they cannot completely discharge. So there is a problem of discharging the material onto the inclined plate. So you can see there is an inclined plate which is attached to this buckets, individual buckets, and while the overturning of this bucket happens, the chute is so narrow at the bottom that they cannot completely discharge the material onto the inclined plane. Then came the semi-cell type of bucket. So in this semi-cell type of bucket, as you can see, there is a transversely sloping cell chute is there. So at the bottom of the bucket, so there is a cut which, when the bucket gets filled, the complete material gets transferred onto a inclined plane, and this is discharged directly onto a conveyor. However, in cell-less type, there is no chute, but there is a ring which is provided just below the bucket. Now, when the material is cut and collected by the bucket, it is directly transferred onto this ring chute, and through this ring chute it directly falls onto this fixed chute which is at the bottom, which again transfers the material onto the conveyor belt. So in cell type, the discharge capacity is less as material acceptance is more, and discharging time from bucket is also less. So hence the cutting speed is limited. So as I said, if we move it at a faster speed, it may not be able to discharge it completely. However, in semi-cell bucket type, so in this the discharge problem was somewhat avoided. However, in this design, the overall capacity of the machine decreases because there is a bucket and then there is a sloping cell chute onto which again it has to discharge onto the conveyor belt. Then came the cell-less type of buckets. In this, the material is directly discharged onto the ring chute, which ultimately discharge it onto the fixed chute. So this design permits greater cutting and bucket speed. Now when we talk about a cell-less type bucket, it looks somewhat like this. So as you can see, there are teeth to the front of the buckets, and then there is a ring chute, and this ring chute would allow the material to fall onto this fixed chute, and through this fixed chute the material is dumped onto the boom conveyor. So this is how a cell-less type bucket in a bucket wheel works. Now coming to the counterweight boom. Again, when we talk about this counterweight boom, they can be again of two types. One is a fixed type counterweight boom, one is a movable type counterweight boom. So you can see here the counterweight boom cannot move as the wheel boom moves up and down. However, in a counterweight boom, where as the wheel boom moves up and down, the counterweight move can also move up and down for balancing the complete machine. Hence, when we talk about a fixed boom, so the variation of the wheel boom, the angle to which it can vary or move up and down is less. However, in a movable boom, the load on bucket can also be varied. It can be more, the load on the bucket can be more, and also the wheel boom can move to a larger extent with a movable counterweight boom. It can move more with a movable counterweight boom. In fixed boom, balancing is not a problem because the fixed weight does not have to be balanced. It is completely fixed. Only the wheel booms moves up and down within the specified limit. However, in a movable boom, the luffing or the lifting range is more. Here, less skill is required for operation. However, in a movable boom, control can be done precisely. So you can we can move the wheel boom up and down precisely with the help of this counterweight boom. In fixed boom, it is less operational noise, there is less moving parts, hence wear and tear is also less. Variation of center of gravity is also small. So, this can accommodate prime movers and other parts, and overall weight is less. So, this counterweight boom can house the prime movers and the other necessary rope winch arrangement can be housed here. So, the overall weight of this machine reduces, as or else this prime mover and the other parts has to be housed on the superstructure. Now, when we talk about the luffing arrangement, as I discussed, it is the upward and downward movement of this wheel boom, and it is also the upward downward movement of the counterweight boom, so that the stability of this whole machine is maintained. Now, how it can be done? It can be done through hydraulic systems. So, where the hydraulic system is just beneath the wheel boom, there can be rope winch arrangement as is shown in the picture, or it can be a combination of rope winch and hydraulic system, where there is both rope winch for balancing and a hydraulic system beneath the wheel boom. Now, when we talk about rope winch, it is simple in construction, can be easily repaired, less noise and precise controlled. Now, when we talk about the swinging mechanism, so this swinging mechanism, if it is electrically driven, it has a swing motor, it has gearbox and pinion. For swinging arrangement, the most important component is the ball race with ring or bull gear, as we have discussed it for shovel. Now, for wheel drive mechanism, again there is, if it is electrically controlled, there will be a electric motor, there will be a tube coupling, and then there will be intermediate gearbox, which gives the power through universal joints and propeller shaft to the either to the bucket wheel gears, where the bucket wheel is rotated, and it also gives power to the crawler mechanism. Now, when we talk about the crawler mechanism and the undercarriage unit, as we have seen in shovel, so there is a ball race and a ring gear. As we can see here, there is a pivot column about which the swinging action takes place. So, there are the crawler mechanism similar to that of the shovel. Again, there is a central grease pump, oil pump and slewing ring as is shown herein. This is similar to that we see in shovel and other machines as well. Now, when we talk about the lubrication system, the lubrication system, they may be of three types. They are the central lubrication plant, there is a gear lubrication unit, and there is a ball race lubrication unit. So, you can see with this droplets that is on the picture shows us where the lubrication is required for the operation of the machine. So, these are the references for this topic. Thank you. Next class we will be learning about dragline. Thank you.